What is fractal thinking? Fractal thinking is a cognitive approach that involves recognizing and understanding patterns and connections that repeat across different scales or levels of complexity. This way of thinking is inspired by fractals in mathematics and nature, structures that are self-similar, meaning they look similar at varying levels of magnification. Fractal thinking allows individuals to perceive the interconnectedness and repetitive patterns in systems, concepts, or processes, offering a deeper insight into how smaller components relate to the larger whole. How fractal thinking differs from traditional linear thinking. 1. Focus on patterns versus cause and effect. Fractal thinking emphasizes recurring patterns and relationships across scales, while linear thinking focuses on straightforward cause and effect sequences, assuming a direct path from A to B. Example: a fractal thinker might observe how economic cycles mirror natural growth patterns, while a linear thinker might only track a single trend like supply and demand. 2. Nonlinear approach. Traditional linear thinking assumes problems can be broken into sequential steps for resolution. In contrast, fractal thinking recognizes that systems often have nonlinear interactions, where changes at one level can affect and resemble dynamics at another level. 3. Contextual awareness. Fractal thinking embraces the idea that local phenomena, the micro, often reflect broader trends, the macro, and vice versa. Linear thinking tends to isolate phenomena without considering their scale-spanning connections. 4. Scalability of insights. Fractal thinking looks for insights that remain valid across multiple scales, whereas linear thinking often applies narrowly focused solutions. Examples of fractals in nature. 1. Snowflakes. Each snowflake has a unique structure, but exhibits repeating patterns of six-sided symmetry. Regardless of the scale, the intricate designs follow a fractal pattern. 2. Coastlines. The jagged edges of coastlines appear irregular up close, but their patterns repeat similarly when viewed from a distance. This self-similarity demonstrates fractal geometry. 3. Trees. A tree's branching structure is fractal in nature. The main trunk splits into branches, which divide into smaller branches, and so on, often mirroring the original shape of the whole tree. 4. River networks. Rivers and their tributaries follow fractal patterns, with smaller streams branching out in a manner similar to larger rivers. 5. Clouds. The fluffy edges of clouds exhibit fractal patterns, with smaller shapes repeating the form of the overall structure. Applications of fractal thinking. Fractal thinking can be applied to diverse areas such as problem solving. Viewing challenges as interconnected systems with recurring patterns helps uncover innovative solutions. Business strategy, recognizing market dynamics that mirror natural growth or decay cycles. Creative work. Artists, writers, and musicians can use fractal thinking to create works that resonate across different levels of perception. By moving beyond the limitations of linear thinking, fractal thinking fosters a more holistic understanding of complex systems,